Hello everyone, and welcome to the next Kaia Stablecoin Summer Hackathon workshop. With me today, I have Garrett from Curve Finance. He works in DevRel at Curve Finance. Say hi, everyone. Give a warm welcome to him. However, my name is Sean. I'm the DevRel community manager over at Kaia. I've been the host of the past many hackathon workshops over the past 2 weeks. So yeah, if you guys aren't familiar with me, sorry. But as with the past few workshops that we've done, because this may be the first workshop that everyone is seeing. If it is, we do have a very quick few slides just to explain a bit of what the hackathon is about and stuff like that. So I'm just going to very quickly share my screen here, just for a very brief overview. Right, so the Kaia Stablecoin Summer Hackathon, it's a mouthful to say, I'm sure. But essentially, it's our flagship global hackathon that Kaia is hosting for 2025. We've basically kicked off the first event on August 25th, so it's been about 4 weeks since we launched, and we've had a number of supporters join in. Yeah, so if you guys have been living under a rock or are just not familiar with all the news, we have extended the submissions due to popular demand because some people basically came in from the last workshop on Friday and be like, hey, I just found out about this workshop. Is there any way we can give me a bit more time to submit and stuff like that? It's been a plethora of them on Discord. So we do pay attention to Discord as well as on the dev forums and stuff like that. So we made a collective decision to extend the submissions for another 5 more days. So essentially, you guys have until this Sunday to submit your presentation, your builders on hacks. Yeah. So just a brief overview. As I mentioned, we kicked off on August 25th at WebEx Tokyo at a side event. And you have until September 21st, which is this Sunday, 2359 KST. Remember, so please do not wait until the very last minute to submit. I know we extended the submissions, but still, this does not mean you should wait, right? Yeah. So I'll find the rest of the dates still remain unchanged. So the final demo day will still be on September the 30th. It'll be at token 2049. So looking forward to seeing everyone, all the finalists. The top 5 finalists will obviously get to fly into Singapore. We do have a small stipend for you guys to fly in. So no need to worry about budget or anything like that. If you're coming from, wherever, we will reimburse you up to a certain point. Yeah, so this stipend is for the top 5 teams. So yeah, just keep in mind. And although it's not compulsory for you guys to fly in, we do recommend you do fly in. Yeah. As previously, we kicked off the registration actually on August 7th, which was about almost like 2 months, almost like a month ago at this point, right? And yeah, so far the total prize pool is a 1 million USD with investment opportunities. However, the direct prize pool everyone will be getting is about 165K. Of which 50% will be unlocked upon project launch. So the difference in this hackathon compared to many hackathons is because we want to prioritize projects that will launch as mini labs on Kaia. So essentially, when you win the hackathon, because let's be honest, no one's going to be paying money to launch anything on the mainnet. Let's be honest, right? Everyone's going to do everything on testnet, right? I'm sure Garrett is laughing right now because he agrees. Yep. So essentially, when you win the hackathon, it's all going to be on testnet. So you'll get 50% of the total prize pool, and only when you launch. And don't worry about the launch. We will be providing you a bunch of investment opportunities, a bunch of support, ecosystem support, everything, all the whole package, stuff like that. Yeah. So just as a quick overview of the timeline again, we launched on August 4th. We kicked off at August 25th. The submission is due in about 5 more days on September 21st. At first, it was supposed to be tomorrow, but we made the collective decision due to the community outreach of crying and the, hey, I want more time, right? So we listen and we hear you. So we gave a bit more time. The rest of the dates to remain unchanged. So September 24th, the finalists will be announced, and we will be in contact with you to figure out the flights arrangements, stuff like that. So if you need, like I mentioned, if you need me, we will refund you the amounts for your tickets up to a certain amount. And obviously the top 5 finalists will all get to fly in at the live demo, which will be all in one inclusive on September 30th. Which is the live demo sessions, the closing ceremony, and the winners announcements. Everything will all be in one event. It's a very packed event, so looking forward to seeing everyone there. So if you're wondering just like, hey, I want to get in on this. I have 5 more days. I'm gonna hunker down and I'm gonna, like work 24 hours nonstop until the submission deadline. Here are the submission requirements essentially, right? So obviously the very first thing has to be a DeFi protocol infra related to Kaia stablecoins, as one of the co-hosts is Tether USDT, if you're familiar, and ecosystem assets, basically the link to GitHub plus UI plus demo. The second one, obviously, it has to be a mini dApp online messenger linked to the DeFi protocol built previously, because the other co-host is Linext, right? Excuse me. So those are the two co-hosts. And thirdly, we need you to create a dashboard on Dune Analytics, because they are one of the major sponsors of this hackathon. So just create the dashboard and submit the public dashboard URL. Settled, right? Lastly, we require a pitch deck. So a docs and link, because we instituted this because we don't want there to be many instances of people submitting PDFs and whatever not. So we simplified it, create a DocSend account and upload it there, send us the link, and we will review it there, right? So lastly, I like to stress, please do not, I forgot to change this date here below, I'm sorry, but please do not wait until the very last minute on September 21st at 2358 or 2355, right? Because the last hackathon, the recent hackathon we did with the Korean hackathon, the Korean stablecoin hackathon, 2 different hackathons, right? There were some people who encountered errors with their submission at the very last minute, and we did not extend the deadline for them. So keep in mind, we will not be extending the deadline any further for this hackathon. Right, this is the final push, because if we extend it any more later, we won't have the time to review everything, right? So please do not. You can obviously, as I mentioned, you can submit your builder at any time. So you can submit something right now, right? You just submit some GitHub fork or whatever, fork something of GitHub, submit it as the project, and then you can change the submissions, finalize it, everything by September 21st. So please do not wait until the very last minute. As I have said, we currently have about almost 30 something plus submissions for the hackathon right now. So we're hoping there'll be a few more coming up. So yeah. So as I mentioned, please do not wait until the last minute. Yeah. So lastly, this is my very last slides before I hand it off to Garrett, who will be talking about what everyone is here for, about Vyper stablecoin tutorial, right? So essentially, if you want to find out more information, scan the QR code right now. I can assure you it's safe. It's a very safe QR code. We're not gonna steal your funds or anything like that. Don't need to worry, right? So essentially, we want the focus of this to build mini dApps with the Kaia native USDT/stablecoins. Go from hack to live launch with direct support. Basically, the top 5 finalists will basically get the support from Kaia with Season 2 and the accelerators. So I do have it on very good account that the judges on the final day will mostly be from very big VC venture capitalist firms. So the top 5 finalists will get a chance to actually demo in front of these people and get real life feedback from what these VCs are actually looking for, right? So lastly, this is not just a weekend hack. This is a stage to ship real products on Kaia and our messengers. So as I mentioned, all these mini dApps will likely go on to the Kaia Wave Season 2, which on Season 1, as just a very quick background, from the over 200 million line users we've had so far for Season 1, we encapsulated almost half, so over 100 million users on the Kaia Season 1 itself. So we have as you can see, we do have the actual user base for you guys to ship your products on and test on. So I think that's the big thing that we want to push, is that, a lot of these small projects always have an issue with getting users to test and stuff like that. So with our program, we've already a proven track record over 100 million users to test. So it's a no-brainer for you guys to come and just try out our hackathon, right? So as I mentioned, the submission is this Sunday. So yeah, looking forward to seeing all the proper submissions and everything. Yeah. So I think this is my last slide. So I'll hand it off to Garrett, who will obviously talk about the stablecoin tutorial. So Garrett, please take it away.
Thank you. 안녕하세요. 나에게 감사했습니다. GM. My name is Garrett Hall. I am a developer relations person with Curve Finance. Super excited to be here. I actually came about this because I was visiting Seoul the other week and stumbled into was asking if I could hang out with the Kaia team. The Kaia team said, "Why don't you stop by this hackathon?" And I was very, very amazed and impressed to stop by this this hackathon that was going on. This is the Sol Stablecoin Hackathon. And I'd heard that there wasn't, a ton of stablecoin energy in Sol, and then I saw this hackathon, and I saw hundreds, maybe even thousands of people in attendance and presenting some really impressive projects. So it was, very exciting to see all the energy in stablecoins. I heard some talk of a stable yuan potentially launching on Kaia. So it's a really exciting time to see all the energy and action going on. Sean, thank you so much for that information as well on the tutorial. On the hackathon, because I didn't know that the deadline was still open, and it's very inspirational. I might also pop in and try and register. I don't currently have plans, unfortunately, to go to Token 2049, although members of the Curve team will be there. So I definitely encourage anyone who's interested in the anything that we talk about here, wants more information, to connect with the team there. But hopefully I can win the hackathon. Apparently I still have a few days left. I could submit something, and I can actually just maybe get flown out to hang out and party with everyone at 2049. That'll be amazing. So hopefully I will win the hackathon and see you there. If not, do connect with the Curve team. One quick note, Sean forgot to mention, but there's a Q&A at the end of the chat. So it's going to be open. If anyone has any questions about anything we're talking about, by all means, you could stick around till the end of the chat and we can talk then. Or I have the comments open in the side window here. So I hope that this can be a very interactive presentation. And if I'm going too fast, if I'm going too slow, if you have any questions about anything in particular, if you want me to double click on anything, if you want to just test me, if you think maybe this guy's an idiot and you can ask some questions and stump me, drop them all in the chat. I am more than happy to answer them as we go live. So I'll periodically shout out some of the comments we're getting. We're seeing some comments asking where the intern is. He's late again and again and again, but probably fetching coffee for everyone, so not a problem. Let's go ahead and get into this tutorial, because I'm super excited to be able to talk with you. And I actually think that a lot of the things that we're covering in this tutorial are going to be very applicable to the points that Sean mentioned in the hackathon. Because some of the things that are mentioned as part of the tutorial is that, for example, Tether is very, very integral part of the hackathon, and you want to be able to build real applications on the Kairos testnet for Kaia, not launching it on the mainnet. And if you want to build any applications with Tether, particularly utilizing stablecoins, you're going to want to have a really solid stablecoin exchange. This is where Curve Finance can come in, because Curve has been around since 2019. It got its launch as a stablecoin exchange, and I've already, through a part of this tutorial, we're going to show you how to interact with the Curve Finance stable swap contracts on the Kaia testnet. So you could actually just take the code snippets from this and work directly. So we're going to be covering throughout this tutorial the Vyper programming language, VYPER. That is a smart contract programming language that is used within Curve and a lot of other DeFi protocols. It's fully compatible with Kaia and Kaia's Kairos testnet. So this entire theme of this tutorial is to learn a bit more about Vyper, but we're also going to give you a real practical understanding of the Curve technology and how to interact with the Curve technology using Vyper and similar tooling. So any questions so far about the Vyper stablecoin tutorial and what's to come, or is there anything that you would like to get from this tutorial? So if there's any goals or anything that you came here to looking for, let us know, and we will be more than happy to kind of modify this. So I have a presentation on screen here, and I just wanted to note that there is also a companion GitHub repository that we would recommend that people follow. So if you go to the Curve Finance GitHub, that's CURVEFI, go to the Vyper tutorial repository, and you'll find that there's a folder within it called Kaia tutorial, which I'm going to be utilizing throughout this tutorial. So you could follow along with everything that we're doing by downloading this GitHub repository to your local machine. And if you are, if you are interested also in a copy of these slides, everything is linked from this GitHub tutorial. So within this GitHub tutorial, I have linked the presentation we're looking at right here. I have linked Kaia scan, information on the curve deployment, and then some of the repositories for some curve tooling, and even some style guides and further tutorials, which you might find helpful. As we're going through here, I see that there is some comments about the Fermento doesn't want coffee today, wants to sleep early. Well, there's a time zone difference here, so it's very late for anyone who's attending this in the Asia region. So definitely appreciate anyone who is tuning in from very late hours. I know that the US and the Asia time difference is severe. It's 5 a.m. here, so I am going to be doing coffee, actually green tea. I already had enough coffees this morning to probably power a small city. So I'm awake. I hope all of you are. If you need some coffee, of course, talk to the intern. That's just at Kaia intern. I'm sure that they can help out. All right, so let's get into the nitty gritty here. And just a quick note, the GitHub repository that we have here has more than we're probably going to be able to tackle here. So the full tutorial that I could deliver on this subject could go for hour and a half. No, sorry, 3 hours probably. We only have an hour and a half. So I'm going to cherry pick what I think is kind of most important to give you a basic understanding of Vyper, give you a basic understanding of Curve, give you a basic understanding of the tooling. But if there's any questions, as Mello points out, yes, I'm reading all your comments. So please keep this interactive. Please ask questions, and please let me know if there's anything you particularly want me to double click on. So quick poll of people who are in the comments, like how many of you are familiar with Solidity, the smart contract programming language? Solidity is probably the most popular smart contract programming language. It's very like JavaScript-like. It's got the curly brace syntax. It's strictly typed, as you would expect a good smart contract programming language to be strictly typed. It is the foundation of so many of the smart contracts deployed to Ethereum, deployed to Kaia, deployed nearly everywhere. With everything we've seen within this industry, essentially, is there's a big first mover advantage. Nearly anything, be it like launching a DeFi protocol or even launching a programming language. So there's a lot of Solidity but resources out there. It's a fantastic language. I use it myself. I used to teach it for the University of Washington. If you are a big fan or big Solidity person, this is not supposed to be like any kind of like programmer beef between Vyper and Solidity. Vyper is just an alternative to Solidity, which I and many of my very technical colleagues really prefer. So Vyper is launched with 3 primary principles. It's focused on security, simplicity, and auditability. So by security, what this means is that Vyper is written in such a way where it is intended to make it, if you're just sort of following the basic syntax of the language, it's supposed to be naturally and by default secure. So there's a lot of examples of things that the Vyper language just does very well to secure things. One of the higher profile instances is this concept that Vyper really pushed forward before Solidity of by default preventing reentrancy. So Vyper has a non-reentrant decorator which you can use. If you're familiar with the history of smart contracts, one of the early black eyes that Ethereum faced is that there was this essentially this early attempt at an on-chain VC called the DAO, where basically it was about something like 10-20% of all of the Ethereum got locked into this early project, which is supposed to be this community governed way of apportioning funding to things. But there was a reentrancy bug, and it was a very early in the Ethereum experience, and this reentrancy bug basically hadn't, Ethereum was still getting its chops as this code is law, everything's immutable on chain, and there was this massive hack that drained so much of the kind of the total Ethereum supply that it led to this hard fork between Ethereum and Ethereum Classic, because as much as everyone believed in this concept of code is law, it really was such a it was such a kind of like considered an existential threat to lose so much Ethereum to a hacker that they rewound, pretended the hack didn't happen. It's kind of early in the Ethereum days. There was trading wheels. So reentrancy has been a significant problem for any smart contract programming language for a long time. Vyper decided to attack this by putting in a reentrancy decorator, but also to advance this conversation on like, in addition to like making it simple to keep the functions from being reentrant, actually was like in the discussion of if every function should be considered guarded against reentrancy by default unless it was explicitly stated the opposite. So these are the sort of security philosophy conversations that go on amongst the Vyper team when they are like trying to like architect and figure out how to make it easy for people who are novices. Because if you're a novice and you don't understand reentrancy, the simplest possible thing is to by default have the code be secure, and only if you like have done the research and have an expert reason why you would want to like enable reentrancy would you disable the default lock. Now, funny enough, while this discussion was going on, it turned out that a kind of earlier version of Vyper had an issue with the reentrancy guard malfunctioning. Curve Finance got hit by this, got drained of a lot of money. Kind of an awful experience. So, that is unfortunate. But that aside, this kind of like based after this, the team tripled down security and has done full audits of all the previous Vyper versions. Vyper is a very secure language. The team has a incredible focus on security, and the fact that this happened once. Feel free to ask any questions about it in the chat because I lived through it. Wasn't a very fun time. But I would say that the Vyper, Curve, overall smart contract programming community that relies on Vyper has only rebounded stronger. Simplicity and auditability/readability are the other big tenets of Vyper. So within Vyper, it's entirely Pythonic. If you're familiar with Python, you know that Python code is, in my opinion, and the opinion of most people, relative to Solidity or JavaScript style curly brace syntax. Very gorgeous to look at. It's got the indentation. You can kind of see the flow of the program by default because the way Python is like just visually appealing by indenting code blocks. It also, Python is just very naturally written, so it makes sense. And a lot of Vyper is directly like Pythonic in that it's like following all the Python conventions. There's some newer stuff that's like arguably not fully Pythonic, but it's Python inspired. And finally, it's intended to be like easy for auditors. So everything about the way that Vyper has been put into place is designed to make it more readable. So if someone is trying to go through and audit your code, they can more easily understand what you're trying to do, what's going on. It didn't allow certain types of modularization at the beginning, because if you ever like opened like Kaia scan or Etherscan and seen just like 15 separate import files, those types of code can be very hard to debug. Vyper waited until version 4, which was just released about a year ago, to do a proper like modularization, because they wanted to make sure that modularization was done in a way that could actually be sustainable and readable and auditable. So a lot of advantages to Vyper. We're going to get to see a lot as we go through. So again, we don't have time to fully live code all 12 steps of this. So the way that we're going to do this is we are going to go through some of the earlier lessons, which are the slower ones where we get you set up with Vyper, set up with a lot of the tooling. If you've downloaded the GitHub repository by now, you have already gotten a chance to kind of preview some of these lessons, and you'll be able to follow along directly with us. So we're going to try and live code as much as we can right up until we kind of start to run out of time, at which point we'll just talk through the remaining lessons at a higher level so you can get through and kind of understand the core concepts of Vyper. These 12 steps are everything that you need to know to create your own lending-based stablecoin. Lending-based stablecoin would be a stablecoin where essentially you take some kind of collateral. So maybe it's the Kaia token, let's say, or maybe it's like the Curve token. Any volatile token, you deposit some amount of it and use it to mint a stablecoin, and you have some way of liquidating the user if the price of that token has changed in such a way where the collateral is not enough to support the position. Oh yes, thank you, Eric, for dropping that. So that's if you missed it, Curve FI is the name of the repository. As the organization, the repository is Vyper-tutorial, and within that you'll find the Kaia tutorial. Although everything in there is good, the 12 lessons are like a full version of everything that was that we're doing, and along with like 12 separate companion YouTube videos, which you can check out, which I've done separately on each of these in a lot more detail. So we're essentially going to speed run the entire Vyper tutorial here. And to get started, we are going to, so we've divided this into 12 different steps. Throughout the 12 different steps, there's kind of a mission that we're going to try and get to by the end of each particular step here. So for the end of this first one, we're going to get you set up with everything you would need to be able to launch your own dummy ERC20 token. So this could have, many uses, even if you don't want to like go through the rest of this tutorial. If you're just interested in launching, for example, like maybe you want to do a meme coin exchange project for the Kaia Hackathon, and you want to use Curve as the backend for it, like everything that you would need for it, you can get, because with just a few lines of code, you can launch your own ERC20 token. It's in the subsequent lessons that we'll actually like hook it up to the minting contract and make this ERC20 token only mintable and liquidatable in the event that it's like using a separate token for it. But dummy ERC20 token is kind of all you need. And just a quick check-in on the comments here. The intern is really stepping it up. So the intern is taking the initiative that's needed to get promoted. So if you're interested in career advice, definitely check out the comments on the X live stream, which is happening concurrently. And if you are watching this on X, like let's get this trending. Let's get this to as many people as possible. Like take a second to retweet this, share this. And also feel free, if you're watching this, in fact, on X, to follow me. My account on X is listed here. If you are trying to find me on like LinkedIn, you can type in this name, GE, like General Electric, we bring good things to life, RR, like railroad, IT, like information technology, Hall, like the Hall of Fame. Or if you're on X or like social, where I try and like be like more pseudo-anonymous, you can see my account here. This is Curve Cap, like left of Curve, and Cap, like capital. Here's a photo of me giving a very different speech a few weeks ago in Hong Kong to the Bloomberg office. But below this, I thought I'd reposted. Let's see, where is it? Yeah, here we go. I've reposted this, Kaia developers. So get this trending. I see 202 people watching it live. That's good. But it's kind of rookie numbers because I understand that there's probably like 2 billion people awake right now. So let's see if we can get this from 202 to 2 billion, right? Maybe intern can help with that. That's the kind of initiative that we need. All right, so if you are, all right, so goal to get set up and launch an ERC20 token. Throughout this first step here, in addition to launching the ERC20 token, we're also going to drill down on all the like Vyper and smart contract tooling that I really like and recommend. I'll walk through each of them a little bit slowly so you can ask questions about it and so you can see how they work in practice, but these include Titanoboa, Snekmate, Curve Lite, PyTest, Mamushi, and Rough. So this will be the tool set that you will find as we go through this. So if you have in fact downloaded the GitHub repository, you are going to see that your environment looks a little bit like this. So there's this README file, which is visible right here. This includes links to all these tools that I just mentioned: Boa, Snekmate, Curve Lite, Mamushi, and Rough. As well as there's requirements.txt, which you can just do a pip install of the requirements to install all of this. So this includes way more than the ones that I just mentioned. But if you just do create a new virtual environment, you could call it like Kaia env. I've already taken, so I'll just do Kairos env. And then within this source Kairos env bin activate, and then pip install -r requirements.txt. This is included. You'll see it's going to go through and it's going to install everything you need and more. It's going to get you Vyper. It's going to get you PyTest. It's going to get you everything that you're going to need. So first and foremost with this, one of the like biggest ones that I want to shout out, in one of the coolest, biggest reasons actually to use Vyper, in my opinion, is Titanoboa. Titanoboa, which has documentation here at titanoboa.readtothedocs.io, and I'm realizing I forgot to include that in the README. So my apologies on that. I'll update that after this is done. Titanoboa is an advanced Vyper interpreter, so it only works with Vyper. It doesn't work very well with Solidity, but it gives you all the like advanced dev tools you could possibly ever imagine being useful. So if you're familiar with Foundry, it's able to basically like give a lot of like advanced type features like that, some of which like aren't included anywhere else. Like one of the biggest things I rely on like my day-to-day like smart contract basis is they have line-by-line gas debugging. So if you've ever been gas golfing to try and make your contracts more efficient, I know the Kaia chain's pretty reasonable on gas prices, but it comes up every now and then where you're like trying to like pare it down to like line by line like gas profiling. You could do that using Titanoboa. We use Titanoboa within this for a number of things, for deployment of some contracts. So highly recommend that you take a look at Titanoboa. It's super easy to install Titanoboa. You can just type, if you don't want to like do the full pip install that I just did, pip install Titanoboa. And we already have it installed, so we didn't have to do anything there. One of the cool things about this is that Titanoboa also works with Jupyter notebooks. So I might have borked my Jupyter notebook just before launching this, so we'll see if this works. But if it doesn't, you can just type Jupyter notebook. And is this going to work? Knock on wood. I think I might have borked it. Nope. We might be in shape. Good luck here. So with Jupyter Notebooks, you can actually like, it's one of the easiest ways to work with Titanoboa and work with Vyper, in that you can actually like, you can actually write some scripts. So here we have like a deploy curve token. You can connect directly to your browser by typing. So all you need to do is import Boa, and you might need to run a specific extension to enable it, which you'll be able to tell because it's when you try and execute it, it's going to give you a line of code here that you're supposed to run. After you do that, you can import Boa, and you can run set browser environment. I set it to Kairos, the testnet, which is chain 1001. And then if this works, this is going to work directly with my Rabby to be able to. No, looks like maybe I did bork it. Okay. But I actually used it earlier to launch testnet token, which I have in this script here. Maybe this one's going to work better for me. Yeah, this one's going to work for me. So it's just that particular script that got borked. So kill that one there. Basically the exact same thing. With Boa, you set it to browser environment to basically say like, yes, we'd like to look at whatever is connected in the browser. Set the chain ID. You could also do it in here, and some watch accounts. But this is my testnet account here. Then once you're connected, you can set the chain ID, and this should now be my Rabby should now be connected to Kaia Kairos testnet. And then I have some Vyper code in here, which I'm going to talk about how I got that in a second. But I just ran this, and it pops this up and should deploy, except as mentioned, I borked my Jupyter, so it's not going to play nice with me. It might play nice with you, though. Essentially, load the contract and deploy it. And in most cases, works pretty good. So the fact that you can actually connect with Jupyter notebooks, and then I could just write some code and send it around to people. Pretty good. In the chat, by the way, it's a pop-in chat on X. Instead of making fun of my Bork Jupyter notebook, you are actually congratulating the intern who got coffee, donuts, pastries. So we're eating good here at this tutorial. And at the same time, the intern is calling 2 billion people to up the numbers on X. So really great work. Really good job, intern. So this is Titanoboa. Snekmate. So I mentioned that earlier. I went ahead and launched this token to the Kairos testnet. Where did I get this token? This is what I did. I'm dumb. I did include the link to Boa. It's just sitting right here. It's called boa.titanoboa because Titanoboa is tough to type. Boa is just the shorthand. You click here, you get to the repository. You can see how easy it is to install Boa, and you can see some basic hello world scripts you could use using Boa. One thing I didn't even mention is that within Jupyter Notebooks, you can actually write Vyper within the Jupyter Notebook cell code using cell magic and execute Vyper code natively. So a lot of cool things that you can do with Vyper here. So here's an example of within IPython writing a Vyper script in this cell in here and then just deploying it. So it's that easy to deploy some smart contracts using Vyper and Titanoboa. Snekmate is the other big Vyper repository that you should be aware of. Snekmate is by PCA Versaccio, who's just done a fantastic job. If you're familiar with Solidity and Open Zeppelin has created a bunch of template contracts that you could use. So for example, if you wanted an ERC20, an ERC721 token, you have the same with Vyper. You have a bunch of out-of-the-box templates that you could use for nearly anything that you might need to use. This became really important when Vyper became modular as a version 4, because you could add in things like simple ownable modules to make the smart contract ownable. Ownable 2-step, so it's ownable by me. I transfer to you. If you accept the ownership, you can take the ownership. All the kind of basic building blocks, which you will often need to enrich your contract with, but you don't want to build it yourself, or particularly because if you're smart, you're auditing everything that you put on chain. So if you don't want to actually audit every single piece of the contract yourself, having a lot of building blocks to use out of the gate is fantastic. So access control, similarly, if you need to have different roles with different permissions, this gives this here. And throughout, there's some extensions. There's some basic token interfaces. And when I deployed the ERC20 token, the way I got this was I popped into here. I popped into lib, or rather, source, Snekmate, tokens, ERC20, and I just ripped this template 602 line ERC20 token, which is everything that I needed. You can see here the building blocks of a basic Vyper contract. One thing you'll note is that the contract is actually more documentation than it is code. So the lines of code are the colorful parts, and the grayed out parts is the meat of this. So when I say it's 602 lines of code, Vyper it plays very nicely with NatSpec documentation. And assuming that you actually document your code properly like this, there's a lot of tools that you can use with the Vyper command line interpreter to actually just pull out documentation or pull out and work with the code base here. And Mello in chat asks if the name choice of Titanoboa was chosen to beat Python. So of course, Vyper is code name. There's a lot of you'll notice a lot of SNEK Snek or SNAKE snake themed references. So Titanoboa is the largest snake on planet Earth. Python, of course, is a snake, but it's not quite as big. Vyper itself, Viper, but Vy to make it more Pythonic. But of course, the Vyper snake. There's an entire snake themed ecosystem here, leading up to Snekmate. Snek being the colloquial spelling here. So as you're looking through the Pythonic Vyper code here, you can see a little bit about how these contracts are organized and how like how it works. But when you look at like the basic functions, you'll notice that like because it's Pythonic, it's like super easy to understand what's going on. So if we look at most of these functions, the external ones are pointing at similar internal functions. The internal functions, let's just pick one out. If you're transferring a token from one owner to another address, first you go through your assert statements. You say, make sure that the owner is not an empty address. Make sure that the to is not an empty address. Pretty obvious, right? Like even if you didn't know how to code, you could read lines 4, 5, 6 here. Make it just a bit bigger so you actually can read it. So you assert that the owner is not empty. You assert that the to address is not empty. If that's the case, then you're going to run this before transfer token transfer function, which I believe is empty for this. It's just an empty function which you can fill in after the fact to run some hook before you transfer the token. If that's the case, then we're going to pull the balance of for the owner by, surprise, surprise, calling balance of on this owner. You're going to make sure that the transfer amount exceeds the balance. So obviously you can't transfer more tokens than you own. Assuming this assertion is true, then you're going to subtract from one user and add to the other user and log the event. So you can kind of see just by reading through this template contract, like Vyper makes sense. Like everything in here is obvious. Like if I was auditing this and I saw, for example, it wasn't crediting the full amount, it would be incredibly easy to understand because it's Pythonic, super easy to understand. Thanks for the shout outs, chat. Respect and appreciate all of you as well. Laughing out loud at the conversation between Kaia developers and the intern. Really, if you're following on X, good stuff. But yeah, it is definitely a nice change of pace for the intern to get support from the speaker. So I was an intern once. I think we all know how it is. So the ERC20 Vyper token, I just downloaded it to the local repository here. And this is where under contracts, I started with token.vy. You'll see the entire contract is here. I have a slightly older version here, so it has been updated to Vyper 4.3. Of course, everyone should use the most up-to-date version, but it's 5 a.m. here, so cut me some slack. You'll notice because I have Vyper, I can run Vyper on the token.vy to get out the bytecode directly like this. But Vyper also, if you type Vyper -help, you can see that there's a lot of formats that you can get from this. So by default, it's just giving you the bytecode. But for example, if you want the ABI or the ABI in a Pythonic format, you can pull it out. And I mentioned that the NatSpec documentation is kind of built into Vyper. So if you're trying to pull out docs, you can type Vyper-f user docs contract token. What did I do wrong there? User doc singular. No doxing. And you can see that it's pulled out a JSON array of all the notice level documentation. Or if I wanted to do the dev docs for developers, because of course we're devs, we can look under the hood here. You can get the dev docs out just with a single command here. A lot of cool things you can do once your contract compiles natively and neatly using Vyper. Definitely recommend to look through Snekmate to get a good sense of some sample contracts. So, all right, so we got a token. The token is working well. The token was in fact deployed using this like very simple script, which I put here in a Jupyter notebook, deploy curve.ipynb, just using this deploy function. Do I still have that open here so we can see what it looked like before I borked? Yeah. Yeah. So with Boa, all we needed to do was we need to load the contract and give it the constructor values and deploy it. So the constructor values for this was just the name of the token, a symbol, number of decimal places, and the domain and the version. This corresponds to, if you look at the init function, and we're going to go through these in a bit more detail, but because we might not get to all of it, I'm jumping around. The init function is, you can see these are the 5 parameters I passed to it: name, symbol, decimals, EIP 712, and version 712. And this is executed as a smart contract is deployed. It's the same as the constructor function within Solidity. You launch this, and it just deploys everything with the parameters that you pass to it. So very simple to launch the token. As I mentioned, there's a few other tools, one of which I wanted to show a live deployment of, but unfortunately it takes like 20-30 minutes, and sometimes I run into issues with gas. So I didn't, I went ahead and deployed this a couple of days ago. But because this is a stablecoin hackathon and you're going to want the capability of interacting and interfacing with Curve, I went ahead and deployed the Curve contracts to Kairos testnet. So for some context, Curve is a DeFi like giant, I would say at this point, because Curve started off as a stablecoin exchange, but then Curve also has the capability of exchanging between non-stable assets. So you can see this. This is the current Curve homepage, and it's got a lot of stablecoins on there, but it also has some exchanges between, for example, let's find a good one. TriCurve here is a pool that has processed $2 million volume in the past 24 hours. And he's exchanging between the Curve USD stablecoin, Ethereum, and the Curve governance token. So that's the crypto swap. Curve is also currently launching FX swap pools, which are pools that are designed for foreign exchange. So, for example, if you're building a stable WON app, you could use the Curve stable WON app to, the FX pools to facilitate trading between foreign currencies, which are like, they have some advantages which are outside the scope of this discussion for building foreign exchange and are being done so by some non-USD denominated stablecoins. And then on top of it, Curve has this Llama-Land lending market built into it, which utilizes its own stablecoin, Curve USD. So there's a lot of amazing plumbing for Curve USD and stablecoins through Curve. And you can see that Curve has been deployed to many chains. Curve is not yet, unfortunately, deployed to Kaia mainnet, but I did you a solid, and I knew that you might want to, for example, launch your own, say you're launching your own stablecoin. You might want to launch your own Curve pool. So I went ahead and deployed the Curve core contracts to the Kairos testnet. And if you are interested in seeing how this works, there is this repository within Curve called Curve Core. Or Curve Lite alternately. And this is a repository which basically allows you to deploy all the plumbing to any chain as long as it's EVM compatible. So this gives you stable swap, to crypto, try crypto, not yet the FX swap, but talk to me if you're interested in that. Maybe we can get something for you. It builds some zaps for being able to like interact more efficiently. It gives you basic governance. It gives you reward gauges, which essentially like are these like if you want to like stream rewards of it could be Curve, it could be any token to incentivize people depositing to the pool. It also includes some registries, which are developer centric contracts that are super useful because they combine all the things like factories where you can launch pools into and all the pools have been launched through any instance of the deployment on chain. So it's also super easy to do. And I have, because I ran this, it says it only took 2 minutes here. So actually, I guess I probably could have done this on chain here. what it did is basically you run python manage.py deploy all, and then I have created a prod/kairos YAML file, which basically said what on chain need to be deployed. And it just ripped through and it deployed all these contracts to a variety of addresses. So if you're interested in seeing these contracts, I linked them here in the GitHub repository. If you click on Kaia scan, this link here will take you to the address that did deploy all of these. So you can see, I gave myself some 50 Kaia testnet tokens a few days ago, and then again found a faucet. Thank you. I don't know if this is your job, intern, or the Sean at the DevRel team. Whoever had a working faucet, thank you so much, because it's one of the things that drives me crazy is when I get like half of a token and it's not enough to actually launch anything. But I was able to launch everything for about 2 Kaia tokens, testnet tokens. So I didn't even need this extra 100 tokens. So I could actually just give it to all of you. If I guess, yeah, why not? First person who drops your address in the chat, we can send you some Kaia testnet tokens. But all the other deployments are right here from this address. This is my, you can see, yeah, I got 98.5 tokens left. Yes, it is intern's job to maintain the faucet. So thank you, intern. Thank you for keeping the faucet full and running. It's the plumbing that we need. You can see all the contracts were deployed here and set up. So any of the contracts by this address are Curve core contracts. You can actually use BOA and or any so I haven't gone through and verified the contract source code on here. So you could go through the process of basically like supplying the source code for these contracts to this if you want to interact with them through Kaia scan. Everything we got through this tutorial is going to allow you to interface with these contracts directly on the Kaia scan explorer. So the contracts are all there, and we can in fact interact with them using BOA. I saw a question came up. I saw a question came up from Asux about Titana fuzz property tests, which is what invariance would I start with to prove that no value is created, destroyed across a mint burn, plus add remove liquidity on Kaia? It's a fantastic question. I wish I wish that I could had the time to get into that. But I will follow up with you separately on that, because it's a great question. So within Titanoboa and PyTest, there's fuzz testing, really robust testing capabilities. And the question is basically like, how are you going to prove that if you're doing a mint burn, that it sums out to 0? So I can basically provide some examples of some fuzz testing that we use within Curve to run some of these like higher level tests to actually like run through and like formally prove certain things. But basically, like the short version of the answer would be, if you take a look at github.com/curvefi, there's a ton of amazing resources within that you could use to. That's right. You didn't have to wait till the end. There's a ton of amazing resources within the Curve repository, and because all the Curve team are really robust at writing tests, you can actually get like some incredible tests examples running through and just looking through some of the testing repositories here. All right. Okay, cool. So the Curve Lite's been deployed. If you want to interact with it, there is a script, which I also think I was bad and didn't fully update, but I will still show it to you all the same. As mentioned, my Titanoboa is borked. Oh, yeah, let's get Jupyter Notebook running again. Jupyter Notebook. And within the scripts folder, I wrote a deploy curvepool.ipynb, and this is from an old tutorial, so I didn't have time to update this with the new RPCs. If you're in fork mode, let's just do it live and see how far it goes before Jupyter Lab borks on us. So what I could do here is I could go to chainlist.org. Chainlink also very good, but in this case, we're going to go to Kairos testnet. We'll grab an RPC. You will probably be able to say better than I am if any of these are good. I'll try this one here. We'll run this in fork mode where we actually try and connect, and you'd have to do 1001, of course, if you were in live. And yeah, my Jupyter is borked beyond repair. I wonder if I duplicate this, if it would work, as I think it's just a caching issue with my browser. Yes, it does seem to work. Okay. And then why would that not be working? Maybe this mode, maybe this one's not forkable. Let's try a different one. It has to be an RPC that allows fork mode. Let's see, did I try that one yet? Okay, so maybe you can answer me in the chat here. Maybe it's not forkable, or maybe I just my Jupyter, so we're not gonna be able to demo it. Let's see. So boa.set browser env. So I could do it live. It looks like it might be so good as to go live, or maybe not. All right. So basically, the long and the short version, the way that this would work if you were actually trying to deploy a pool using a functional copy of your Jupyter notebook, is what you would do is you would set, if you're in fork mode, you would set an RPC. If you're live, you would set your browser environment. You hard code the addresses. So this would be, in this case, the 2 tokens that you were trying to launch a pool for, and a 3rd token representing the factory. From this, you would actually load an instance of the token, load an instance of the factory. You could see that it's using the BOA load ABI method. What you do is you give it the ABI, and the Curve core repository here actually includes the JSON files for all the AMMs, so you can just pull it directly from Curve core. Then you would load, use that ABI to load object for it. Because it was already deployed, you'd use .at to get the factory address, and this is the Curve core factory. Curve light factory is just a like what it says on the tin. Factory, you can use it to launch pools from it, and then the factory will itself maintain a record of all the pools that were launched through it. So after you have launched it using the factory, then you would be able to load an instance of that pool. In this case, by looking at the particular implementation. So this was a pool launch between a volatile and a stablecoin. So this is using the crypto swap to crypto swap implementation to represent volatile to a volatile two assets that do not expect to maintain the same price. To actually deploy the pool, you would come up with an initial price of the token. We selected 69 because it's good for memes. We deployed it. This is again for the Berachain tutorial. So apologies. This is should have been updated to Kaia testnet. But you'll deploy the pool. You don't need to care too much about these parameters, but there is a lot of resources on the Curve documentation that explain what it means, or you could just copy these parameters directly. It's good for volatile assets. It's what the browser would use if you go through the factory to launch a pool. And then you're calling the deploy pool function. So after that, you'll get back a deploy address, and you'll actually have a pool contract that you can interact with. So had my Jupyter been working, then you could see, for example, the balance that was funded to the pool, which should have been 0, but oh, sorry, this is the balance of the user. So the user was gifted 1 million or 1 billion tokens, one for each person that's going to be watching this tutorial by the end. The pool has a price oracle built in, which is one of the advantages to using Curve pools, is they use really good EVM-based, usually oracles, which are safer because they have kind of this lag built in, so sudden price spikes don't immediately move the price. So recommended if you're building a stable swap, there's advantages to using the Curve pool as your price oracle. You still have to be very careful whenever you're working with oracles on chain, but so it goes. And then we have a function here that approves and adds liquidity for this pool. So after the pool is done, it calculates the right amounts given this starting price and deploys it. So all this code, because my Jupyter is borked, you could pull it into a script and run it as Python. A lot of people really like Jupyter notebooks, so we try to do as a Jupyter notebook, even though it doesn't play nicely with our machine, apparently. Let's see, what did I miss? Borked code is proof it's live, otherwise just a pre-recorded tutorial. Exactly. Don't worry then, a lot more bugs to come because I'll get into the live coding soon. Incidentally, if you are using AI, AI is actually pretty good at coding Vyper, but please, for the sake of everyone, do not just vibe code something in Vyper on AI and deploy it. Like, please get some audits. All right. 2 more tools to talk about. They're pretty cool tools that I like and use very frequently. So let's get rid of Jupyter because we already mentioned that's our proof of humanity. Mamushi and Rough. So these are linting tools. I'm not going to give too much time for them, but Mamushi is very cool because as you're writing your contracts, the contracts will compile even if it's ugly. But Mamushi will actually like look through the contract and fix like weird formatting errors. So for example, if I went through contracts token.vy and let me like put in some sort of bug in, not bug, but like something that like just, you know, let's add some extra spacing or something that should, if I run Mamushi on my contract now, it's actually just going to go through and reformat the contract and fix it. Mamushi, of course, has options to show you what it's fixing. So if I, let me do that again, just like do some weird spacing in here. So yeah, there's like weird spaces in here. Like that's not good, right? If I run Mamushi, for example, check, it's going to say like, oh, you know, look, bro, look, sis, it looks like your token.vy contract's pretty good, but you know, there's some issues with oh boy. It looked at everything. It would reformat this particular file here. Well, what's it gonna do? What would you actually do if we reformatted it? So here it's actually reformatting all the imports here, which you can see it didn't run in everything. But there's quite a lot of lines that it would, so I didn't even need to put a bug in here. There's quite a lot of lines that it would say like, you know, you commented, but you should have a space between this comment and that. Or, you know, this here is not fitting the line length properly. So it, we took this 1-line statement, it moved it into 3 lines. The end result of this is you end up with some gorgeous code. You can use Mamushi within your GitHub checks. And then you can also pass like config files. So if like you don't care about multi-line line length, or you have a different custom line length, you can adjust that. So generally within Curve repositories, it's standard practice to have linting checks before you actually can commit the code. Mamushi is one such tool. The other is Rough. Rough does not make life rough, makes it very good, in fact. And here's the Mamushi repository, just so you can see. This is written by Ben Burr, primarily, and you'll notice a few of these people are Curve contributors. Pip install Mamushi works well. You can run also in place false to just output the results to the console instead of overwriting. So to show what that would look like, if I did Mamushi contracts token, and then just in hyphen place equals false, it would not actually run it. It would say, here's what it would look like after it's done. Fantastic tool. You could see the pre-commits. You could see passing arguments like line length. Great tool. Rough is another linter. It's very fast. It's written in Rust. You know, we see that Rust is extremely fast, 0.29 seconds relative to some of the Python ones. That's always the knock against Python, is it's kind of slow. So it's kind of funny that it's a Python tool written in Rust, but it is very good. Rust is going to basically combine a few of the other Black and ISort, if you're familiar with those. Those are some standard linting tools that are very good. Rough does all of those as one. So you can run rough check on all the files in the directory. You can pass py project toml file, which we do include in the repository that we give to you. And it's got over 800 lint rules. So Curve has its own like special rough. It's compatible with Flake 8 as mentioned. So if you're familiar with Flake 8 or if you're familiar with Black, you can see right here, it draws on both of those. You're going to find it very easy to use rough. So those are the primary tools that we wanted you to be aware of for using Vyper. So we talked about Titanoboa, Vyper, how to install it. Here's some more information on Titanoboa. I showed how to install it using pip. You could also use Poetry and UV. We talked about Snekmate, which is the building blocks that's going to give you everything that you need to launch basic contracts. Curve Core, you can launch this on any testnet. We've already launched it for you on Kairos, so you can use it to actually like run some stable swaps. Here's what it looks like as it's being deployed. It's safe to rerun. It also stores the deployment details. So if you need those, let me know. I can add those to the repository. Haven't done it yet because I am bad. Last one to talk about is PyTest. And we already saw a question about testing. Curve very strongly uses PyTest. In fact, some of the cool tools of Titanoboa is you can see test completion percentages. So after you've run PyTest, you can actually like run through and see what % coverage your tests have. You can see color coded summary line by line of like how thoroughly you've tested different areas. Unfortunately, I don't have an example to show, but yeah, PyTest strongly recommended. So this is all the resources that we've pasted into the, this will look familiar because these are the same resources as exist in our README file, as well as some links to some style guides for Vyper, for Curve, if you're interested in like knowing a bit more about this, as well as ApeWorks Academy has some fantastic resources on using Vyper. And I realize I haven't checked in with the chat in a hot second. So let's see what's going on. 90% of hackathon debugging is just convincing Jupyter to remember imports. Isn't that the truth? I actually don't like Jupyter notebooks unless I'm doing like something that involves visualizations. And even then, yeah, it's an issue. For the Snekmate library, which mixins are a must-use for hackathon grade stablecoin integrating with Curve? I would say that none of them are actually like must use necessarily. I like the ownable function, but remember, if it's DeFi, you might not want an owner. So the Curve core contracts deploy like very basic like DAO contracts. So with the Curve core deployment, for example, if you want to have contracts that were owned by Curve or owned by a DAO, you can look at that for an idea of how you can basically like work with Curve. So Curve, of course, has like pioneered VE tokenomics. That is written off of Aragon and the VECRV for the voting weights. So it's a very complex system. It works great for Curve. Not all DAOs in their early stages are so nice. So if you just want to have like, trust me, bro, I own this contract until I pass it off, then you can use ownable two-step. Do I have a simple wiring example showing access control for mint burn that's easy to flip from test to mainnet? Yeah, in fact, the token.vy that's included here is pretty much all that you need. I have basically extended this with some other tokens that just basically import the ownable module. I will try and find that after I'm not. As you know, it's like a little bit tough to multitask to like both code and talk and do all these things at once. But when I get like a chance to like just unitask, I will get you some simple contracts. But it's really as simple as just kind of instantiating and importing the ownable module. We actually kind of cover imports with only 20 minutes left. I won't get through all of it, but we'll speed run through some of this so you can see how imports work. But this token implementation actually does come with, it uses the ownable module. So it's I've included the not ownable two-step, but the ownable module within the imports folder. So this is just the exact same, slightly older version, but I imported the ownable function here, which is the access control. So when it launches, this token here directly has an owner. So the only difference between this and the two-step is when you do the transfer ownership, the transfer ownership is going to it's going to move it to a new owner. It's going to make sure it's not the 0 address, but it's not going to require the new owner to accept it. So you do want to be careful with this, because sometimes, like for example, if I tried to transfer ownership to a smart contract on accident, and that smart contract didn't have the capability of interfacing with this contract, then the ownership gets burned, right? Like I have already sent this to a smart contract, and the smart contract, if it doesn't at least have the accept ownership function built into it, it might just you might have like just accidentally like fat fingered it and like send it to a smart contract, and then the ownership is irretrievable. So that's where like the ownership two-step is really useful. But this is a like FO type transfer ownership. Person gets it within the smart contract. I hope that answered your question. If not, feel free to ask it again in a different way. All right, so this is like the basic hello world. We've set up our environment. We're ready to roll. Next, we've launched a token contract, but if we're going to build a lending-based contract in 20 minutes, which is really, really a lot, we would need a minter contract. So we'll go through and actually just create a very basic contract, working with Vyper, and then we'll talk through the rest of the steps. But to get a contract going, I'm a dinosaur. I use Vim. So don't recommend anyone else use Vim, because it's a little bit confusing. I can't answer questions on Vim. I don't think that's the best use of our time. So hopefully we won't get into too many of them. But I'm going to put together like a very basic version of a smart contract. The first thing you need to know is, in the same way that with Solidity at the top of the contract, you have to say the version. Similarly, like Vyper supports Pragma version, be it a caret to say that it's above any version at that level or above, or you can have it be specified to an exact version. So the way that this works is the first line in your contract should just be version. We'll do 0.4.3, keep it live. And this here is, I believe, a sufficient contract. Let's see. I'm in Curve Core still. Let's see if in this window I can run Vyper contracts minter. And it technically does not compile because I have v 4.1 installed. Okay, well, all right, so be it. So we have here just a super basic contract that compiles. Not very inspiring, but yeah, it works. So that's pretty good. Version Pragma. I don't think there would be too many questions about that, but feel free to drop them if there are. One of the cool things with Pragma is you can also set it to optimize. And I don't think that this is something Solidity offers, but when you're writing your contract, you could optimize it for code size, which would save... it would save the cost of deployment if you have a super complex contract that might cost a lot to deploy. And maybe it's like a read-only contract, so maybe gas doesn't matter. Or if it's like a contract that's doing a lot of writing, it's by default going to optimize to save gas. So this is useful when you're gas golfing. It's also a compiler option you could set. But you could just add that to the Pragma. You could say, let's do, let's optimize this for code size. And I don't know if our very simple contract would be any different here. I wouldn't imagine, but you could, for example, do that. We saw earlier that functions just look like this. They're Pythonic. They have to be declared with the scope, be it external or internal, depending on the visibility. But if we want just a very simple function, we're going to call this a mint function. So this is a minter contract. It's going to, the way that this stablecoin setup we're going to put together is going to work is you will call the minter contract when you're like giving some token. The token will, let's call it the Kaia token. Let's say it's a Kaia-based stablecoin. We'll send Kaia to this contract. This contract will make sure there's enough Kaia. It will then call the mint function on the stablecoin token contract, presuming permissions are set, and then it will just go ahead and mint. So very basic Pythonic syntax is we would do something like this. We'd say it's an external function that can be called. Of course, we need to add permission checks. We need to add all sorts of stuff. But as far as basic building blocks, we've got now a slightly like longer smart contract because instead of doing this, it's doing that. You could see, for example, -f external interface. And we can see that like where before there was nothing, it was just an interface for a minter with nothing to it. Now we have a def mint function. Another way you might see the interface would be like this. Basically the same thing. External def mint ... And then the last thing that's worth mentioning is that Vyper really, really encourages you to do it right, to actually put code in doc strings into your contract. It can use a special form of it to provide this rich documentation. So within the doc strings, there's a bunch of both contract level and function level documentation that we just strongly recommend that you adhere to, because this contract is like, I don't know what's going on with this. What's the point of this contract? But if I actually like document it, I say the title is a Kaia stablecoin minter. I say the license is MIT. I say the author is Curve Cap at the Kaia stablecoin hackathon. I say that the notice is that you're going to mint a stablecoin backed by Kaia, and I say that as dev notes, this is just a sample implementation of a minter contract. Do not use in prod. So hopefully if someone sees this, they're like, oh, I better not use it. Similarly, like we can document the mint function. We can say mint any quantity of stable coins, dev, not yet implemented. Maybe 3x's. And now I can extract the user docs or the dev docs from my minter contract. That was just user doc. What was it? Vyper help. Okay, no hyphen. Vyper user doc contracts minter. And you can see we're like, oh, okay, cool. Now I understand what's going on with this contract. Now I've got like 20 contracts. I can just rip it and automatically like create developer documentation out of it. Yeah, you can see where that could become pretty useful. This can be done, as mentioned, the function level when you're passing params. It can show the return value. Highly recommended that you be nice and document your code. These also can pass through directly when being deployed to Etherscan. I don't know if the same would work with Kaia scan, but you can actually have like the function parameters like make your like life easier when you're visiting this on the Block Explorer. So with the mind of time, curve infer equals modern, Garrett's edit equals fossilized remains. Curve like is actually like surprisingly big fan of like text only interfaces. If you saw the original Curve website, it was gorgeous. It looked like a Commodore 64. And it's one of the things that attracted me. I identify as Gen Z, but my chronological age is that of like a baby boomer. So when I saw this like ancient looking, here we go. Here's what it used to look like. Way back in the day, Curve used to look like this the founder, Michael Egorov, he's a coding genius. He's also like most at home in like a Norton Commander style interface. So when he sees like this like gorgeous text-based thing and is processing billions of dollars of TVL at the time, like we got a lot of respect for like old school interfaces. Let's see here. I saw more comments coming in. Intern, yeah, we need the pastries. Look, it's like 6:20 a.m. here, and I have not eaten. What's going on? Reminds me of Windows XP. That's probably like a generation faster than we're going for here. All right. We're gonna speed run the next 10 minutes just to get you up to date on the very, very basic bare bones concepts, because we're not gonna be able to live code this whole thing. I hope the live coding was instructive, but because I got so personally mortally wounded by your offensive comments about Vim, I'm guessing that maybe we shouldn't quite do that. So snapshot. If you look at the snapshot directory within this, you can also see all the incremental steps as we were going through and building this out. There's a so step 1's done, step 2 is done, step 3. We'll speed run this here. So this is what documentation looks like for a good smart contract. Step 3, we talk about variables. So the goal with step 3 is like we want to create a mint function, and in the process, we'd like to introduce this concept of like how do variables work within Vyper. So variables are declared, with their default type. So there's different types in Vyper, just like there's different types in Solidity. You access them using the self object. So pay attention to the scoping of this. Self is an environment variable that's used to reference the contract from within itself. And it also has itself some special properties. So for example, if you call self, it'll just return the contract's address. If you call self.balance, it's going to say, what's the actual balance of the contract in the chain native token, for example. So if you wanted to, for example, like just have your contract say, like what is the what's the balance, then you would change your minter function to say like returns balance and then returns self.balance. What we're trying to do here with step 3 to show this off is we are trying to actually like make this start to mint something. So the way that this looks by the time it's done is I don't think I quite well, I think in this, what I did was I updated the token function to actually like run this mint function was, I believe, the difference. So if you look at the contracts token and you look at the mint function, it's not complete in this version. So there is a token, but I actually obscured the logic that existed within it to show off how the variables work. So the way that it works when you're done is the mint function actually goes through and it references state variables, which is total supply. Total supply and balance of are state variables for the contract, which are defined basically outside any variable that's to initialize it, you put it outside the scope of a function. So in this case, we are instantiating total supply as a public uint 256. And you're instantiating a hash map, which is the same as a Solidity mapping, to map the address to the amount of tokens that are stored. So in this token, we were actually like fleshing out the balance of and the total supply, and we are updating those when we go through this mint function. So this mint function goes through and updates this. This is an example of it accessing the self, the state variables. A few different types to be aware of. Address is an Ethereum or Kaia address. It has to be checksummed, so be careful how you write it. That means you have to have OX and you have to check the capitalization of it, or it might complain, because Vyper is like very strictly typed like that. It tries to be secure and help you avoid making mistakes. It stores it very, very compactly, so you can store massive amounts of addresses without using up too much storage space. Addresses have themselves properties. So if you have loaded a variable as an address, you can, for example, get that address's balance. If it's a smart contract address, you could get the KEC the hash of the code at that address. You can get the code size from the address. You can see if it's a contract or not. So you can see if it's an end user or smart contract deployed to that address. And for example, like we mentioned, like the pitfalls of transferring ownership to a smart contract. You might like not allow it to be transferred to a smart contract. You can actually get the bytecode of that address. Unsigned integers. There are anything from anything up to 256. You can also have signed integers. Unsigned integers are for, of course, storing positive, and signed integers if it's can be negative. And then we also saw an example in this code snippet here of assert statements. Assert statements are how you can, in this one, we actually just go through and restrict minting functionality. We have assert that the minter is who it says it is. So assert that the message.sender has been authorized to mint. Otherwise, it's going to pass this dev revert message. This is a pretty cool feature of Vyper in that it has these developer revert messages, which I'll explain in just a second. The way they assert, so you notice here this, we're asserting that the minter is the same as the message sending it. Of course, someone has or something has to be calling a smart contract. It has to be an address. Within Vyper, this is accessed via MSG, special variable, which inherits certain properties. So you can see the message.sender is the person that sent it. You can also see if they included any value with the sending it, which you can access as msg.value. And then you can get some data that was passed through it if the message is passing data. If the message has remaining gas, you can use msg.gas. We also notice that this here is self.minter. This is returning a Boolean, Boolean being true or false. That's a different type. And here we point out some of the logic that you can use when you're dealing with Booleans, just a logical true or false value. You could do some math on it that's very Pythonic. And then with revert statements, there's two different types of revert statements you can do. You could just do a classic revert statement, which would look like this. So assert x is greater than 5, if not, comma, and then the revert statement, which would mean if you're running this on the, like, for example, EVM or on Kaia testnet, it would return back a friendly, hey, this failed because the value is too low. I'm sure if you're developed, you've come across cases where revert statements are awesome like this. Now, that being said, Curve doesn't usually deploy on testnets. Curve does all of its testing in a like using Titanoboa and using dev tools. So there's a lot of argument, like, is it meaningful to like use gas to include these dev revert statements? Because strings are pretty expensive. So you can include dev like revert messages like that. Just know that if you're in a gas poor environment, it can cost a lot. So the alternative would be dev revert statements, where it's Titanoboa is capable of giving you the error message if you're using Titanoboa. But if you are not using Titanoboa, it's just going to revert. But the presumption is that, like, if you're a good dev, you are sophisticated enough to try and like run this in a forked environment and figure out, like, extract the dev revert reason through a sophisticated debugging tool like Titanoboa. So not saying you have to do it, but if you want to save gas for your users, you can use these dev revert reasons. And then when you're dealing with a BOA, and if you want to extract the dev revert reason, it would look, there's a boa.reverts, which can be used to either like verify that the revert happened with a particular string, or if it's a dev string, you can pass the dev equals to get that dev revert reason. Oof. Chat, you are exploding. You're exploding here. Oh, that's what happened. The interns just eating the pastries for themselves in the pantry. Okay, well, Your blood glucose is going to spike if you do that. You got to share some. Pantry raid. Woof. That's getting a little spicy for 5, 6 in the morning here. All right, very good stuff. Their interns getting the help that they need. I wish that we had the time to get through everything else. The key statements, I'll just lightning round here. You saw a bit about how you can use Vyper on the command line to extract interfaces. So we already kind of covered this out of order here. It's a cool thing. You can use these interfaces within the smart contract itself. So if you type Vyper-F external interface, you're going to get something that you can paste right into the contract, which will allow you to interface with, appropriately enough, an external contract. So we're at step 5 here. By the time we get to our Minter contract in step 5, our Minter contract has now included an interface to interface with our token and mint against it. So you can see that this is starting to get fleshed out, this Minter contract, where we're starting to include some state variables of the stablecoin. It's got an initialize statement where it's actually setting the stablecoin as an address we supply when we deploy it. The stablecoin is now minting by using this mint function externally. There's no protection, so anyone could just go and mint as many of the stablecoin contract as we like. But as we proceed through, now that we've accessed the interfaces, we see that there's different decorators like external, internal. There's a few others, like you can make your function pure, which means your function does not read the contract state or environment variables. So maybe it's just doing simple math. We saw the deploy statement for when you're initializing. A view statement is not going to be altering the contract state, so less refined version of pure. Payable if it's receiving, if it be able to receive raw Ethereum, or in this case Kaia tokens, and non-reentrant is the decorator to protect it from reentrancy. So we'll skip over this because we saw it. By step 6, we are importing the interface and using it to protect the mint function. So here's where we actually just run the Vyper code to actually pull it out. And we're also pulling in this ownable function, which we saw elsewhere for how this contract could be given this. You can also import interfaces very flexibly. You can import it from the Vyper file interface if you created an ABI type interface, or even directly from a Vyper file. So by the time we get to step 6, our contract is looking more like it's now evolved, where it's starting to get kind of complicated here in a lot of ways, because now we have both a what did I type caps lock? So now we've got we're defining not just a stable coin, but we're also defining a lending token. So this might be wrapped Kaia we're sending to mint it. We're adding some assert statements, which you can see. Has the lending token been approved before we can mint it? Has the lending token been given to us in sufficient amount? We're passing a parameter to the mint function to make sure that it is capable of doing it. And for interfaces, we're actually importing an IERC20 interface, which one of the nice things about Vyper and Snekmate is you can actually directly import IRC20 interfaces. So you have a standard out-of-the-box functional ERC20 token you can work with. So now, for example, we can pull, because we've defined lending token here as an IERC20, we're able to actually pull the balance of it. It gets access to this balance of function because ERC20 tokens have a balance function. Similarly, like now we're importing the token, which is just in the same folder as this token. So when we import it here, it's a token that's been deployed at this address, and it now inherits all the properties of token. So there's a transfer from function on the lending token where we send it all the tokens, and then we have a mint function. It inherited this mint directly from the stablecoin. Yes, Asux, there's a public link to the slides. So I think I'm out of time, so I'm not going to be able to get through the remainder of the steps. But you can see all these slides as well as all the steps here. So if you saw earlier Curve-Fi Vyper tutorial, Kaia tutorial, there's all these snapshots. So you can work through the rest of the 12 steps, or you could go through the full Vyper tutorial. which is not using Vyper 4, it's using Vyper 3, but as you can see as you go through, it's very close, and go through video lessons for each of these steps in much greater detail. The link to the slides is here in Kaia tutorial under presentation. So if you click presentation on Kaia tutorial, that's just going to take you to all these slides, and you can see them, you can fork them, you can do anything you like with them. So I believe I am over my time limit, but I think we said we were going over for questions. So now would be a fantastic time to drop questions into the comments. If not, I can, I can do whatever you guys need. Sean, you guide me. It's your show.
Yeah. Thank you, Garrett. I'm sorry you ran out of time. I'm sure the participants would have loved to continue on, but as Garrett mentioned, you can find all the tutorials here. github.com/curve/Vyper tutorial. It's all here. I will try and get a link from Garrett and post it on the comments below in as a follow-up tweet below, so everyone can go follow it later. I think there was a question at the very beginning that you did miss. I know you've been paying very, very close attention to chat, which I very do appreciate. I think chat also does appreciate that. But there was a question, something that we can really do very fun on StreamYard is we can actually show the questions on screen. So I can show this. Yay! Excuse me. Yeah. So
I wish
for
I'd known that.
implementing,
That's so much more fun.
yeah, that's why I was like, hey, did you want me to do this? But you kind of answering questions as you were live, so I was like, just leave it be. Okay, so the first question is from Asugs. I'm not sure how to pronounce the name, but yeah, for implementing EIP 2612 permits on Vyper on Kaia test.mainnet, what's the recommended pattern to ensure safe approvals into curve pools without replay issues?
Yeah, that is a great question. So I don't know the answer to that offhand, because I know that there's some interesting things you can do with curve pools. For example, one thing that they actually have built into the newer generation of curve pools is gasless approvals. So you can, within the same block, you can send the balance to the curve pool and then execute a transaction. Which might be the proper way to do it. I don't know if there's a 2612 permit way of doing it, but the gasless approvals is best, but you'd have to be careful because it has to be done within the same block. So it's best to do, it works really well if you're using it within a smart contract. So you could, for example, do a Vyper smart contract, which would necessarily execute within the same block, but it wouldn't be recommended to do it, for example, through Kaia scan. So I'm going to say that that's probably the best way to do it. Instead of just doing safe approvals, would be to do the gasless approvals. But I will look and see if there's a preferred way to do that with just the permit function. Great question. And it's I have to say, go ahead.
No, I was just gonna say, yeah, it's an interesting thing. The chat questions the questions that chat asks are sometimes very in depth. And I think
Oh, it's
we've had a number
fantastic.
of questions. Yeah. So I will find a way to maybe get all the questions in a very nice format and paste them in the follow-up tweet below. Once, because I'm sure all basically this entire recording is actually also it's also archived over on our YouTube channel. So, I mean, it's down there, the one at Kaia Chain on YouTube. So if you want to go and rewatch this and see everything, go ahead and, show that. Yeah. So you can go ahead and watch the first part tutorial as well. I'm sure the link also that Garrett provided has all the reset video tutorials, much more in-depth stuff. So this was very good taste as to what you can expect from the videos, I guess. Yeah. I think that might be all the time we have for today. We are a bit over time, because I think if we keep it more time, people will just kind of tune away, right? As with normal things. Yeah. So, before we leave, before I end it off, Garrett, I do this all the hackathon tutorial people, like the speakers, right? Do you have any final words for the hackathon participants going out for the next 5 days? Any parting words of wisdom?
I would just say that if you have any questions about, if you want to use, for example, Curve in your app, I would be very happy to help out. So feel free to reach out to me. As mentioned, you can try not to keep this in writing because I try and keep this name a little bit secret. like fine for video, but in print, then I'm in a country where, depending on who's in charge, I could go to prison for talking about
Oh
smart
no.
contracts. um, uh, but yeah, reach out to me on Twitter. It looks like a lot of you are watching on X, so feel free to follow me on X. I will go ahead, and if I recognize your names here from the chat here, definitely be happy to follow back. DM me questions, ping me in public. We're really happy to walk through the process of, as mentioned, like I deployed the Curve core contracts onto Kaia testnet. I hope you use it, and if you have questions or issues with integrating with it, please reach out. I'd be happy to help. Don't even need to be listed as part of your team when doing so. Although if you want to list me as part of the team and I can share the prize menu with you, then I'd be very grateful to that course too.
Yeah, absolutely. I think, yeah. So if obviously, I think you've already mentioned if you want to find out more information about, you can follow him at CurveCap in his comment somewhere there. I think his link is on the thing. I think he'll share the link at the very start of the presentation. So yeah, can you remind me what Curve's X handle is? Again, is it at Curve Finance?
It's the Curve X handle is Curve Finance. That name there that I mentioned, that's my Telegram. Just all one word. If you want to ping me on Telegram. So those are the channels where it's easiest to get in touch with me. Feel free to add me on LinkedIn if you're like that type of person.
Yeah, absolutely. Yeah, I think that's all the time we have for today. I'd like to thank Garrett for taking time out of his very busy schedule, especially from 5 a.m. all the way until now almost 6:40, almost 7 a.m. So I appreciate him taking time out of his early morning to come and give us this workshop tutorial on Vyper, especially the stablecoin. I think the chat was very active today. I think you've been paying attention to chat as well, which is a very nice thing. Yeah, so if you want to find out more information on Garrett and Curve Finance, follow them. Their X handles are somewhere are all over our X as well. If you want, as usual, please follow us on Build on Kaia and at Kaia Chain for more information, especially if there's any more for more news on Hackathon. Please do scan the QR code there, I think, or there. I'm not sure where it is because StreamYard or YouTube or whatever does tend to flip your video, so it may be flipped. So I might be pointing in the completely wrong direction, but my QR code is up there in the corner or somewhere there. I'm not sure where it is to find out more information on the Hackathon. And yeah, please remember the submissions have been extended until this Sunday, but please do not wait until the very last minute to submit in case any errors occur, right? So please do at the very least submit it by Saturday. I think because you can always finalize it a bit later. So yeah. So without further ado, we can just end it here. Take care, everyone, and we'll catch you all at the next one. Okay, bye, everyone.